we
Yeah, yeah. Hi, hello, everybody. And this presentation is about the search algorithms in the artificial intelligence, and we are submitting this to our professor, David Thai, and we are three people in the team: Srikant, Kondal Rao, and me. And in this, we will discuss about the search algorithms, its importance, and how different types of algorithms, comparing them in this presentation. Yeah, such algorithms like in every industry, in the software industry, wherever we go, we need such algorithms to search for the employee data, right? Or for example, if you take Uber or Ola, if you book a cab from your location to other location, you need the search algorithm to find the best path to your destination. So this also comes under the artificial intelligence stream. Like along with some, we have something like problem solving and expert systems. And such algorithms is also one of the main important key terms in the artificial intelligence. We have like rational agents in the AI. These use the search algorithms to get the best or the optimal results. While coming to the search algorithms, we have two types mainly: uninformed and informed. Uninformed is in the sense they don't have any information. They just will go through they just need to find the path, or they just need to search for something in they don't have any knowledge, domain knowledge. But informed have some knowledge, and they apply some functions, heuristic functions, and they try to find the best way. That's the difference. And uninformed, we have many algorithms like BFS, DFS, cost search, uniform cost search, iterative deepening, bidirectional search. And in in informed, we have hill climbing, steep hill climbing, A star, AO star, BFS. This is best for such algorithm. In this, like in informed, they will apply some heuristic functions such a way that we get the best possible route. But the informed, uninformed, they don't have any function. They won't calculate anything. They just go to the destination. So they are brute force. Informed are heuristic. They will apply some conditions. And coming to first, we'll go for the BFS. Sorry. We know BFS is breadth first search. This works with the our data structure called queue. We know queue. It's a FIFO, first in first out data structure. The same way it works. We will be extending level by level in the BFS. You will be expanding all nodes in the first level of the tree initially. Then you'll go to second level. In the second level, you will explore all the nodes. You'll go to third level. You'll go to fourth level until you reach the goal state. You will be going level by level. This is BFS. For example, we will take one example. For example, if in this we have an example, we have a graph here. Like we have a table. This table is like we have open list and closed list. Open list is nothing but the nodes we need to visit. Closed list is closed list means the nodes we have already visited. We are tracking them in the table. And in this we have a graph. This is a unidirectional graphs. We have different types of graphs like unidirectional, bidirectional. This is unidirectional. Here, like we will start at 1 and our goal state is 8. How it works in BFS is first we'll go to 1, next we'll go to second level, that is 2, 3, 4. And here we don't have our goal state, so we'll go to next level. Next we will push 5, 6, 7. We don't have the goal state. Next we'll go to 8, because for 9 we don't have any direction from 5 or 6 or 7. But from 7 we can go to 8. So finally we will reach the goal state 8. But we will follow in this path 1, 2, 3, 4, 5, 6, 7, 8. This is how it works in the BFS. And next my friend will explain about the DFS and compare with algorithms. Yes, Srikant, you can go.
Yeah, thank you, Sai. I'll be explaining the DFS, depth first search. It is a search of a destination node. That is, the depth first search expansion starts from the source node and goes up to the deepest unexpanded node. In this, the frontier is the actual depth stack in the depth first search, which functions as a last in first out, which means the element which is at the last will be the first out. And it is implemented using the stack. It is also known as recursive algorithm. This is a recursive approach for traversing tree, graph, other structures in depth first search. The depth first search is named after the fact it begins the root node and follows its greatest path before going to a next path. And DFS is implemented using these stack data structures. And DFS algorithm works in a similar way as the BFS method. And we have an example in the next page. Here we can see the example for the depth first search. We have the open list and the closed list. From in depth first search, we will go to the first root node as 1, and the root node is connected with the 2, 3, 4, as we can see. and we will go to route 2 as it is in ascending order, and then we will be moving to 4, 3, 6. There the goal state is 6, and next the connector nodes are 4 and 3, and we will pick goal state as 3. And next we will be having 4 and 5 as the nodes, and we will be picking up 5 as the goal. And we have next a 4, 7, and 7th is the goal state. And lastly we have 8. It is a 8 is a goal state for DFS for this example, and we have 1, 2, 6, 3, 5, 7, 8 as the goal state. And next I'll be explaining the best first search greedy search. The best first search is a mixture of BFS and DFS. It always selects the path which appears best at the moment. It uses historic function, and search best first search allows us to take advantages of both algorithms. With the help of the best first search, at each step we can choose the most promising node. Best first search can switch between BFS and DFS by gaining the advantages of both of the algorithms. This algorithm is more efficient than breadth first search and depth first search, and it can have an unguided depth first search in the worst case scenario also, and it can get up to stuck in a loop as a DFS. The algorithm is not optional. The closest cost is estimated by historic function, which is f of n is equal to g of n, and we'll be seeing this best first search algorithm mostly when we don't find path from the DFS and BFS. So best first search is a greedy search, which is the most efficient and possible path selected other than this BFS and DFS. And next the complexity of algorithms. It is decided, the complexity can be decided by the space-time, optimality, and the completeness. The complexity can be measured in the amount of time, the algorithm time to discover a solution. It means the complexity that the algorithm will take to complete the solution, which is the complexity of the algorithm. And in memory complexity, the amount of memory required by the algorithm to complete that search, the amount of memory used for this algorithm, which can be explained in the memory complexity. And next, optionality. The algorithm solution will be the optional or not. So in this case, this optional case is used whether to take it as optional or not. In completeness, in calculation guaranteed to find an answer where there isn't a one or not, regardless of whether the search algorithm is the part of a Boolean maker. And the next slides will be explained by the KK Kondalrao.
Yeah, hi, my name is Kondalrao Kandimalla, and as explained by my team members of the previous algorithms and search algorithms that has been mentioned in this previous slides, and I will going to say the realistic application of the search algorithm in aviation industry to avoid the weather implications in like thunderstorms for aircraft. So how to avoid, like there are different it is a very hard for the aircraft to face the thunderstorms because the flight ending like it will face flight damage, cause the damage for the flights, so aircrafts and all. So this the algorithm is the main algorithm, the search algorithm is to identify the best, shortest, and feasible path for the by taking the radar image, 2D image. So it will give the path with the lowest cost estimation path. So this the aircraft pilots will make this they follow the path, so they make with the less efficient cost way. So so this algorithm has this in this paper they have explained about this algorithm and how it's been the approaches, what approaches they have been followed, and like what are the things they have been did in the algorithm. So let me go to this next slide. So this algorithm takes this radar image of the thunderstorm and then decide to determine the safest path. It will be it's a 2D image and it will be captured, and then there is in the thunderstorm there is a different variation, like a heavy and lowest level, and mid level is there. So if we go to the next next slide. So if you can see this here, this is the radar image, 2D image. It has been converted into the matrix type. So to detect where the blue area is where lowest efficient, like lowest area where this doesn't have any effect if it travel if the aircraft travels on that path. So the such algorithm find we need to avoid, the aircraft need to avoid the red colored area. So and then along with the target want to pilot want to go to the shortest, making the minimal decisions and minimum turns they need to make, so to make the efficient shortest path. So if you go on to the next slide. So how this search algorithm works here in this situation. Here the function has been decided with one heuristic function and another is evaluation function. The both functions has been combined to give the shortest path. With the decisions made, the function has been evaluating all the available paths nodes that has been available here. With all the sample test cases they have tested it, so it's been working. And if here the function g will be giving the actual cost incurred in the reaching the node n, and the second one is a which is a heuristic function and estimating the cost of getting from node n to the goal state. It means goal state is the end of the path where it needs to aircraft need to be the goal, it reach to the goal with the minimal effort of minimal shortest path. So if you go into the like there are few constraints over there for the aircraft to meet for this search function. So there is a like few that constraints are minimal flight minimal turns, and they need to make let me give maximum turning angle, minimum number of turns they need to make. The other constraints, and other constraint is minimum segment length, the distance between the flight path and the goal state path. So these are the three constraints. Like in keeping these three constraints, the algorithm has been developed. So this algorithm will be taking the picture and then will be dividing each part of the thunderstorm into grids, placed into the grids, each grid. So in the thunderstorm intensity, like if the intensity is red color means the intensity is higher. So where the 25 decibels, more than the 25 decibels. So if it is less than 25 decibels, which is a green color or blue color, so which shows this less intensity in the thunderstorms. So so this algorithm will consider all these constraints and then makes the decision algorithm. So um yeah, so look, to begin, if you go on to the next slide, if you can see, the A star search algorithm will be taking the 2D image of a radar image, where it need to length is the let L be the length of the target entire length of flight to journey from the two node n to the goal state. So and it need to avoid the red colored high intensity areas. And to begin with it, the minimum segment length of the number of turns that are allowed in the flight path. The segment lies divided into k segments, like multiple segments they have been divided into multiple segments, and it need to make so however the search tree, how the search tree has been applied is like, if the one starting point and end point are the main are not the thunderstorm for the thunderstorm. So the root node of the search tree will be searching starting point, the terminal point is end point. So considering that there is a parallel lines will be drawn onto the thunderstorm. So the airplane flight path will be neither has a 2 point. The starting point and end point lies in the inaccessible region. Inaccessible region in the sense the thunderstorm having the high intensity, so it need to avoid that high intensity area. So this heuristic function is developed like find the actual cost, which it is a line length L, and which it need to avoid, make the minimal turns to avoid the all the such algorithm that need to identify this path. So beyond this yeah, so if you go to the conclusion, so like, okay, go on to the next slide. Yeah, so this conclusion will be but there is some drawbacks in this algorithm also, because the thunderstorm need not to be the 2D, right? So in which in realistic thunderstorm will be is a 3D. So this algorithm doesn't works on the 3D images. in the real time to say. But they had tested with 2D algorithm, but it may work with the path, but not in the altitude level. So another disadvantage is like the processing of this is the radar image has been converted into the image 2D image to process into the grids in the sense like matrix, I can say, data set, I can say, like so, like 2D set, 2D data set. So to process this, to make the decision, like to give the efficient shortest path, like the processing time will be more, like to decide the best path. So like even with the MATLAB, it has taken 11 seconds to identify path. Like even the decision is be more faster need to for aircraft. So one does these drawbacks has been for this algorithm. Like this paper, in this paper they have explained for this algorithm, but they have made the modifications. They find this another SMS star search algorithm technique to reduce the time and space requirements, and to store that such a long image and to process the find the shortest path. They have gone with the newer on the SMS star A star search algorithm technique to like to find the efficient and the fastest way to reliable path. They have been to decide the for aircrafts. Yeah, this in this application, like I say, conclusion I can say, like they have used AI based A star search algorithm to identify the best possible path for the aircrafts. That's what I can say. Yeah. Yeah. Next, about the next slide, it is having the references links. We have been gone through the throughout the paper like presentation. Yeah.
These search
Yeah,
algorithms
Sai.
like have many real-time applications. Like
Yes,
all the
yes.
algorithms have its own importance, and they're used in the industry in the real-time applications, and they're solving many problems currently. Yeah, and thank you both of you.
Thank you.
Yeah, thank you, team.